The next question. A jet airplane traveling at a speed of 500 km per hour ejects its products of combustion at the speed of 1500 km per hour relative to the jet plane. What is the speed of the latter with respect to an observer on the ground? Meaning, let's say I'm the observer, I'm standing on the ground, I look at the jet is moving in this way, and the combustion gases, whatever it releases, it moves in the opposite direction, correct? Right? So meaning what they're telling you is the products of combustion, that is 1500 kilometers per hour, correct? So with respect to the observer on the ground, that is the speed what he is looking. Meaning here, see, the relative speed concept comes into picture. Jet is moving this way, the gases are moving the opposite direction. If two objects are moving in opposite direction, then what do? We have to add the speeds, correct? Yes, we have to add the speeds. That's fantastic. That's correct. But in this case, see, now the relative velocity, whatever we have got, and the actual speed of the combustible gases, or we call it as smoke. Okay, the velocity of the smoke and the velocity of the jet. Three things are there, right? So now what we'll get is 1500 is equal to the velocity of the smoke plus the velocity of the jet, opposite direction, correct? So since these two are opposite direction, so 1500 is equal to V plus 500, so V is equal to 1000, correct? We will get it as 1000, that's not the point. The point is, since it's in opposite direction, we have to represent it as minus 1000 km per hour, correct? Because velocity, it's a vector quantity, right? Magnitude wise, it is 1000 km per hour, but actually what you have to write is the velocity is equal to minus 1000 km per hour. Okay, that's the final answer for this question. Understood, right? So 1500 is equal to V plus 500. So if you take the 500 that side, that will give you 1000, but you have to represent it with a negative sign because velocity is a vector. Understood? So we'll see another problem.